Hello everyone, welcome back to the channel. In today's session, we will move one step deeper into microcontrollers with lecture 3 pin diagram of the 8051 microcontroller. In this lecture, we will understand how the 8051 microcontroller is physically structured using its 40 pin configuration. We will cover four important parts. First of all, the complete 40 pin diagram of the 8051 microcontroller, where each pin has a specific function. Second, we will explore the input-output ports, port 0, port 1, port 2 and port 3, and understand how they are used for input and output operations. Third, we will discuss the power supply pins and oscillator pins, which are responsible for providing energy and clock signals to the microcontroller. And finally, we will understand the control pins, which manage important operations like memory access and execution control. By the end of this lecture, you will clearly understand how each pin of the 8051 microcontroller works and why it is important in real-world applications. So let's get started. Now we will see the recap on the architecture of 8051 microcontroller. Actually, we have seen previous lecture something we summarize here, right? First of all, features of 8-bit microcontroller, right? 8051. Second thing we have already discussed in the previous lecture, architecture of 8051 microcontroller, right? Third thing, on-chip resources in 8051 microcontroller. Fourth, program status word. Already we have seen in the previous lecture. Now we come on today's lecture. Right? After the completion of today's lecture, we will learn, first of all, identify the pins of the 8051 microcontroller and their layout. Okay. Second thing, explain the function of pins, including input-output ports, control signals, and power connections. Right? Third thing, apply pin diagram knowledge to basic interfacing and embedded circuit design. Right? Now, pin diagram of 8051 microcontroller. First of all, the 8051 microcontroller is one of the most popular and widely used 8-bit microcontrollers in embedded system. Right? Second thing, it has a 40-pin dual inline package DIP, right, layout. This is the layout of the 8051 microcontroller. We can say the 40 pins. We can start the pins of this pin diagram. Basically, first of all, we can see the notch. The notch available from the left side of this notch, we count the numbering of the pins 1 to 20, 21 to 40. Okay, these are the pins, right? Now we will discuss the one by one pins. Third thing we can see here, each pin has a specific function. Suppose these are the pins 1, 2, 3, 4, just like pin until 40, right? Each pin has a specific function ranging from power supply, input output ports, timers, serial communication to interrupts. Okay, these things are involved in this microcontroller, right? Now we will see here in the detail. Understanding the pin diagram is crucial, right, for hardware interfacing and circuit design, right? First of all, we can represent or we can see here the 20 number pin connected with the ground. Okay, pin number 9 connected with the reset pin. Pin number 9 is called the reset pins, right? Next thing, we are using here the pin number 19 and pin number 18. We can say the 18 and 19 pins are connected with the crystal oscillator, right? You can see here this is just a symbol for crystal oscillator, XTAL1, XTAL2. Ceramic, just a crystal oscillator, and this crystal oscillator connected with the ceramic capacitor. Okay, so we will see in the interfacing of this. Now we come the port number 0, right? This is the port number 0 of pin number 40, that is the VCC supply we connected here. Basically the pin number 40 is a 5 volt supply, right? VCC is the 5 volt supply, right? So our starting of the port 0, right? 39 to 32. Okay, so we can represent this port. This is basically the P0 port, but we can represent the pin wise of this P0, right? Port P0.0, P0.1, P0.2, P0.3, P0.4, P0.5, P0.6, P0.7. Okay, so these are the pins of the port 0, right? This port also called the addressing lines, address as well as data. AD, you see here AD0, AD1, AD2, AD3, AD4, AD5, AD6, AD6. A represent the address, D represent the data. So we can use either addressing purposes or data purposes, right? Remember? Okay. Now we come on the port number 2, right? The port number 2 start from 21 to 28. Okay, this is the port number 2, right? So we can represent the each pin of the port number 2. P2.0, P2.1, P2.2, P2.3, P2.4, P2.5, P2.6, P2.7. Okay. The port number 2 basically connected for the addressing purpose also, right? 8 addressing line we are using from the port 0. Next addressing we can start from A8 to A15. Okay, so we can say the remaining addressing line we can take from the pin number 21 to 28. Remember, right? Next thing, port number 1, right? So pin number 1 to pin number 8, that port is right? Represent the port P1, right? Next thing, we can connect the another port, pin number 10 to pin number 17, right? This port is called the P3 port, right? So pin wise also connected this port here, P3.0, P3.1, P3.2, P3.3. P3.4, P3.5, P3.6, P3.7. Okay, this is the port 3, right? Now we come on the some other specific pins. So one by one we will see here. Remember? Okay, the port number 3 also usable for RxD, that is represent the received data, right? Pin number P3.1, that one represented for the transmit data. Okay, P3.2, that is represent the interrupt 0, right? P3.3, this is the interrupt 1. Okay, P3.4, timer 0, T0 we can say, P3.5, T1, right? Another pins, P3.6, that is the write pins, and P3.7, that is the read pins. Okay, so we can use as per the demand. Okay, okay. Now we can start the another pins here. Okay, you see here the pin number 31, that is connected with the EA. Okay, this is the external access. Okay, this is basically purposes for the external connection, right? Pin number 30, that is also the ALE, address latch enable pins, that is also called the program, right? Next thing, program store enable pins, that is the 29 pins, right? We have completed all the parts here. That structure is called the pin diagram of 8051 microcontroller, right? So you remember this thing, the pin diagram, each pins of the 8051 pin diagram you learn and remember all the things, right? Each pins you know, I expect from you, right? Next one, we can start the how does the 8051 behave immediately after a reset signal is applied, right? So we can see here program counter PC is set to 0000H. The CPU starts execution from address 0000, remember, right? All special function registers are set to their default values, right? Input output ports P0, P1, P2, P3 are configured as input pins, right? That is all bits are high. Stack pointer, that is SP, is initiated to 07H. Interrupts timers and serial communications are disabled. Okay. Now we will see the pin diagram of 8051 microcontroller. First of all, pins 1 to 8 represent the port 1. Okay. It can be used as input or output purposes. Okay. This port does not need pull-up registers, right? Since it already has pulled up registers internally, right? Upon reset, port 1 is configured as input, so ready to be used as an input port. Okay. Next thing, when the first 0 is returned to a port, okay, it becomes an output. So to reconfigure it as an input, one must be sent to the port. Okay. To use port 1 as an input port, it must be programmed. Right? Next thing, pin number 9, reset pins. Right? It is an active high pin, that is, if the RST pin is high for a minimal of 2 machine cycles, the microcontroller will be reset and terminates all activities. Right? Next thing, during this time, the oscillator must be running. Okay. After reset, all the internal registers are cleared except SP, right, stack pointer. The stack pointer contains 07H and all ports are having FFH. Okay. Now we can start the more explanation of this pin diagram, right? So pin number 10 to 17, right? This represent the port 3, right? Port 3 also acts as a bidirectional input-output port with internal pull-up registers. Okay. Next thing, additionally, all the ports 3 pins have special functions such as upon reset, port 3 is configured as input, ready to be used as an input port. Right? When the first 0 is returned to a port, it becomes an output. Okay? To reconfigure it as an input, a first must be sent to the port. So to use port 3 as an input port, right? It must be programmed. Remember? We can see here the port 3 basically. The port 3, first pin P3.0, that pins represent the RxD, that is the serial input. We can say the read data. Okay. P3.1, that is the transmit data, serial output. Okay. P3.2, that is the interrupt 0, that is called the external interrupt 0. Right? This one. P3.3, that is the INT1, external interrupt 1. P3.4, that is T0, that is called the timer 0 input. right? P3.5 T1 timer 1 input, right? P3.6 that is WR, represent the write. External memory write. P3.7 that is read, external memory read, right? Next thing we will see pin number 18 and 19, that is represent the oscillator pin, right? So XTAL2 and XTAL1. The 8051 has an own chip oscillator but requires an external clock to run it. Okay. A quartz crystal oscillator is connected to input XEL1 pin number 19 and XEL2 that is pin number 18. Right? The quartz crystal oscillator also needs two capacitors of 30 PF picofarad value. Right? So we can represent in this way. First of all, we will see here, right? XTAL2, that is the pin number 18. This one, right? This one, the pin number 19. Okay. So pin number 18 to 19, the parallelly connected here, this one, right? This is the crystal oscillator. This crystal oscillator, one terminal connected with the 30 picofarad values capacitor. This is the capacitor, ceramic capacitor. One terminal connected with the oscillator, another terminal connected with the ground. That is the thing of the capacitor. Another capacitor also connected with the ground. One terminal is ground. Another terminal connected with the crystal oscillator. Okay, XTAL1. This is the way to connection with the 8051 microcontroller. Okay. You see here, suppose we are using this crystal oscillator, the connection is required in this way. But we are using here the external oscillator signal, we are connecting here as a signal, okay, as a pulse, right? So we can connect with, this is pin number 19 only. One pin is required for connection of this external oscillator signal. Another pin we cannot connect, that is the not connect pins, NC, right? Another thing, this is the ground connection, this is pin number 20. Okay, this is pin number 19, this is pin number 18. So external oscillator signal connected with the pin number 19. Remember, right? Next thing, if you use a frequency source other than a crystal oscillator, such as a TTL oscillator, right? It will be connected to pin number 19, XTAL1. XTAL2 is left unconnected, or we can say the NC, not connected. Right? Pin number 20, that is the ground. Pin 20 is the ground pin of the 8051 microcontroller. It represents 0 volt and is connected to the negative terminal of the power supply, right? Pin number 21 to 28, that is connected with the port P2, right? These are also bidirectional pins, input output pins, but with internal pull-up registers, right? Upon reset, port 2 is configured as input, right? Ready to be used as an input port. When the first 0 is returned to a port, it becomes an output. To reconfigure it as an input, a first must be sent to the port. To use port 2 as an input port, it must be programmed. Okay. In addition to acting as input output port, port 2 also acts as a higher order address when external memory is accessed. Okay. Port 2 is also designed as A8 to A15. Remember, right? Now we come on pin number 29, right? This pin connected with the program store enable pins, right? Which is used to enable the external program memory, right? Pin number 13, that is the ALEPROZ, address latch enable, right? So this is the programming thing. Using these pins, external address can be separated from data as they are multiplexed by 8051 microcontroller. During flash programming, this pin acts as program pulse input, right? This is the PROZ connected here, this one. Pin number 31, EA, that is the external access, right? Or this is the thing, programming enable voltage. Okay. External access enable pin, that is allows external program memory. Okay. Code from external program memory can be fetched only if this pin is low, right? For normal operations, this pin is pulled high. Understood? EA BPP equal to 0, then 8051 microcontroller access from external program memory, right? ROM only, right? EA pins, that is equal to 1, then it access internal, right? And external program memories. This situation for the internal and external program memories, right? During flash programming, this pin receives 12 volt programming enable voltage. Okay. Now we will see here the pin number 32 to 39, port 0, right? This one. So these are also bidirectional input output pins, but without any internal pull-up register. Remember here the port number 1, port number 2, port number 3. All port not required the external pull-up register. These ports already connected with the internal pull-up registers. But remember, the port P0 is required the external pull-up register. Right? Next thing, we need external pull-up registers 10k ohm to use port 0 pins as input output port. This is because P0 is an open drain source, right? Unlike P1, P2 and P3. Okay? So this is the thing. This is the microcontroller. Okay, this is port P0, right? This is also the 8 pins port P0 to P0.2 not to P0.7. Okay, you see here, this is the line, this one. But our aim to see here, this line connected with the pull-up register. Okay, pull-up register is required. This one, this is the pull-up register. This one, this one, this one, this one. This one connected with the VCC, right? This is the port 0. Pin number 40, that is the VCC, right? Pin 40 is the power supply pin to which the supply voltage is given plus 5 volt, right? Now we come on the summary, right? In this session, we explored the 40-pin configuration of the 8051 microcontroller. We learned about, right, the four parallel ports, that is the P0 to P3 and their dual functions. Okay. Power supply pins VCC and ground, and the oscillator pins XTAL1 and XTAL2. The reset pin, its role in system initialization. Control pins like EA, external access, PSEN, program store enable, and ALE, address latch enable. Right? So now this is the complete thing, but we will go for the next class. Right? In this next session, we will explore how the 8051 microcontroller organize its memory, including program memory, data memory, and special function registers. Remember, है ना? We will see in the future lecture number 4. Okay? So sample questions already given in this slide you see, right? Draw and label the pin diagram of the 8051 microcontroller. Explain the alternate functions of the port 3 pins in the 8051 microcontroller. Describe the roles of control pins EA, ALE, and PSEN. Why is port 0 considered a dual purpose port in 8051 microcontroller? Right? Understanding each pin is like learning the alphabet of the embedded systems. Master it and you can speak the language of the innovation. Right? Thank you very much for listening me.